Hello, my name is Oscar Holbert and I will be presenting my final year project, InfoFeed, a smart feeding monitor for neonatal and paediatric care. I would like to begin by thanking my amazing supervisor, Dr. Faye Marsbenrad, who has been an ongoing support and has had a considerable input throughout. Breastfeeding newborns has provided protection, nourishment, and developmental advantages throughout human evolution. Breast is best is the advice provided by the World Health Organization to encourage new mothers to breastfeed. Breastfeeding has a wide array of benefits to the baby, as it provides a perfectly balanced diet that satisfies a baby's nutritional requirements. During breastfeeding, antibodies are transferred from the mother to the baby to boost their immune system as they become exposed to bacteria and viruses for the first time. Furthermore, studies have correlated breastfeeding with a reduced risk of sudden infant death syndrome, also known as SIDS, asthma, obesity, and other allergies. As well as providing for the baby, breastfeeding also has many health benefits for the mother. Breastfeeding reduces the risk of breast cancer and ovarian cancer, whilst also preventing postpartum depression and type 2 diabetes. It is also known that breastfeeding reduces the period of postpartum infertility as well as reducing stress. But above all, breastfeeding creates a unique and lasting bond between mother and child, which satisfies the emotional needs of both the baby and the mother. At birth, 96% of Australian mothers opt to breastfeed, but by the second week, only 50% of mothers are breastfeeding. Fast forward 5 months and only 15% of mothers are still breastfeeding, despite Australia's dietary guidelines recommending exclusive breastfeeding up until 6 months. So what is the reason for such decline? A study by Catherine Brown and her colleagues demonstrates that both concerns regarding milk supply and inconvenience and fatigue are the joint main reasons mothers stop, accounting for approximately 50% of the test population of their study. Other reasons such as personal decision, returning to work, and lack of support were also common reasons. This project aims to assist the group of mothers with concerns over the amount of breast milk ingested by their baby by providing a hardware-software package capable of detecting swallowing events and accurately quantifying the amount of milk ingested. Current devices with similar aims were used to provide inspiration in design considerations, although devices on the market are scarce, as many have proven unsuccessful or are still in the early stages of development. MilkSense is a product produced by an American company that claims to measure the amount of milk in each breast, measure the amount of milk consumed each feed, track the baby's weight gain, and understand when breasts are fullest. The operation of the device is centered around measuring the resistivity of breast tissue before, during, and after feeding. However, this company can no longer be found online, and the product is only sold on resale sites such as Amazon. Another American company, MumSense, provides the same functionality as MilkSense, but instead uses a microphone placed on the baby's neck to quantify the milk supply. The product allows users to listen to live playback via the headphones and accompanying mobile application. Despite the potential of this product, the company has discontinued it and are now focusing on IVF solutions. As a result, this product can only be found on sites such as Amazon. Perhaps the most promising product currently on the market is the Coro breastfeeding monitor sold by the Irish company Coroflow. This product uses a nipple shield with a built-in flow rate sensor capable of measuring the amount of breast milk during each feed. Despite the potential of Coroflow's breastfeeding monitor, the requirements for testing and ethical considerations would be too difficult to proceed with a similar device in this project. So instead, inspiration was taken from MumSense and the use of a microphone to record swallowing events, and additional sensors were implemented in a novel manner to address the open market. Introducing InfoFeed, an initial prototype of a smart breastfeeding monitor. The hardware offers a small yet comfortable handheld sensing device packed full of sensors that will be placed on the baby's neck during breastfeeding. The device is wired to the control box, which offers the user simple functionality such as power on and off. It also contains a micro USB charging port and an SD card input to back up recording data. Accompanying the hardware is an Android-supported mobile application currently in developmental stage. Once complete, the application aims to provide the user with a clean and easy-to-learn user interface, providing key functionalities such as communicating to the device to begin a new recording, ability to add remove patients, and analyze and play back previous recordings. Furthermore, recordings saved onto the SD card have been post-processed in an attempt to eliminate the background noise with the aim to emphasize the swallowing sounds. The scope of the project can be separated into three main activities. Firstly, hardware and firmware, which involve the design and construction of the device alongside implementation of sensors and analog circuitry. Followed by the mobile application development through Android Studio, and then signal processing and sensor validation using MATLAB to remove background noise and to create ROC curves for each sensor. The initial design of the project was well represented in the final product, although minor changes were made throughout. Initially, Monash 3D printing services were used in an attempt to make a one-piece sensor apparatus. However, due to the size constraints, the 3D print did not deal with the finer details of the drawing. At this point of the project, the COVID pandemic had peaked in Victoria and Monash campus was not easily accessible, so instead CNC machinery was used to create the device. The device was now proposed to have the egg cup shaped centerpiece with tightly fitted caps either side. The first prototype with this strategy was made, however the device was much too large for newborn babies. The final prototype, which was used in testing, was a downsized version of this, with slight alterations to the sensor cap to further reduce the size of the device. The unique shape of the device aims to focus the sound from swallowing into the microphone located at the center of the device, whilst also accommodating space for other sensors. Furthermore, the face of the device contains a piezoelectrode pressure sensor and dry electrodes to contact the baby's neck during breastfeeding. The microprocessor controlling the device is an Arduino Nano 33 BLE, as it provides high processing power, Bluetooth capabilities, and supports a wide range of external functionality. This is exploited to implement the MyoAware muscle sensor to obtain an EMG signal, the Flora accelerometer to determine the device acceleration, micro SD breakout board to store recordings, and the micro LiPo charger to recharge the lithium polymer batteries used. Much of the signal processing is built into the breakout boards used. However, the electric microphone requires analog circuitry used to amplify and filter the signal before being passed to the microcontroller. To amplify the signal, a simple inverting amplifier with an adjustable gain via a potentiometer at the input resistor was applied. Following this, an anti-aliasing low-pass filter was implemented via a second-order Sallen-Key circuit. As the sampling rate of the audio was set to 2.4 kHz, a cutoff frequency of half the sampling rate, 1.2 kHz, was used to prevent aliasing. Development of the InfoFeed mobile application was conducted on Android Studio to make use of the simple user interface design and the ease of debugging. Signal conditioning and plotting of results were performed on MATLAB due to its signal processing toolbox. As already mentioned, the device is only in preliminary stages of development, although some functionality is already present. Once opening the application, the user is welcomed with the home page, where there are options to begin new recording, select the user, view and play back previous recordings, or go to settings. The user select page provides a list of currently created patients, whilst also providing the functionality of adding new patients by using the add button at the bottom of the page. The form needs to be filled out with all fields required before adding the user. By selecting the View button adjacent to the patient brings their profile up where the user can edit or delete the patient. Prior to recording, it is important a person is selected in order to save the recording in the correct location. This can be done by selecting the tick box. After a user has been selected, navigating to the recorded sample playback page will provide a list of previous recordings. There is an option here to pause the audio signal obtained from the recording, and a delete button if a recording was accidentally taken. Each provides collected information in the form of date and time, number of swallowing events detected, and an approximate amount of milk ingested. To begin a new recording, it is important to have Bluetooth enabled to connect to the device. This can be done in settings where a Bluetooth toggle switch is used to access the device's Bluetooth. Once toggled, the available Bluetooth devices can be searched for. Once paired to the Arduino and a patient has been selected, recordings can be done. A new recording can be performed by pressing the Start Recording button, which will communicate to the control box and begin sampling. The Stop Recording button will terminate the sampling and save that information to the current patient's file. There is also a Switch Patient option at the bottom if the wrong patient is selected and needs to be changed. Now we are all ready, let's take a recording. To begin a recording, the control box must be switched on to provide power to the microcontroller and the device. Once switched on, it's important to initiate a recording, which can be done via the mobile application. Once a recording has begun, the red flashing light will appear on the control box. Placement of the device is important in order to get the best results. Following several tests, the best location was found just to the side of the larynx. Bottoms up. The data was saved to the SD card, transferred to a computer, and the results of the recording are plotted via MATLAB, which provide clear insight into each swallowing event. During the recording, a swallow was performed approximately every second for a total of 7 swallows. These plots show when these swallowing events occur using data obtained from the sensors and allow for implementation of a simple swallow counter. This is the audio signal obtained from the electric microphone. It contains a high level of background noise, so digital filtering using MATLAB was performed in an attempt to limit the effect of noise during the recording. This is what was achieved. To conclude this video, it is important to outline future improvements of InfoFeed. Firstly, in terms of the hardware and firmware, a more appealing and colourful hardware design would improve the aesthetics of the device. As well, a higher order analog filtering circuit for the microphone would help improve removal of the background noise. Further, to improve circuitry, a specifically designed PCB could be implemented, which would also limit the size of the control box. In terms of the mobile application, further work is required to debug all known issues and ensure reliable connectivity between mobile and InfoFeed device. Once this is achieved, and the application is up and running, support and availability for all Apple devices would be required to accommodate for a large portion of the market. Lastly, the signal processing of the project was more of an afterthought in an attempt to optimize the audio recording. More sophisticated noise cancelling techniques could assist in this in future prototypes. And lastly, a simple swallowing counter was implemented by analyzing the peaks of the waveforms. However, the algorithm would need to be improved to quantify the amount of milk ingested depending on the amplitude of the signals. The device itself works at a fundamental level to distinctively characterize a swallowing event using the implemented sensors within the device. However, testing of the device was performed on adults, and as a result may not work to the same efficacy when testing on babies. Moreover, many of the elements that comprise this entire project are only at elementary standards due to the time restraint, COVID pandemic, and the lack of knowledge in certain fields. As a result, the product can only be classed in preliminary stages, and much more work is required to improve the device to a level where it can be marketed. Despite this, at the beginning of the project, the aim was to design a device that can detect a swallowing event to address the challenge new mothers are experiencing every day, the fear of underfeeding their babies. It can be said that this project has successfully done this and hopes to act as a stepping stone for future prototypes. Thank you.